Okay, components. We did this briefly on Friday. I think I need to do it again, over and over again, until you learn them, live them, love them. Okay? You got to.
What are components?
Components are the horizontal and vertical parts of a vector, made up of a little bitty unit i's and j's. The legs of the triangle. Yeah. That would have been faster. Components.
Little bitty.
Legs of triangle.
Is that off or at?
Off. Of. Mr. Bellavo cannot write.
We all knew that already.
Is not fluent.
That's why you're a math teacher.
That's right. Is not fluent in his native tongue. Okay. Components are the legs of the triangle. I'm going to draw a generic, and I'm redundant too. I'm going to draw a generic vector here. This will be vector A. This is everything you need to know about this vector. You may need to know this angle. To find this angle, you may need to pull out some of your mad inverse sine, cosine, and tangent skills from Algebra 2 and Pre-Calculus. Okay? This side length will do the double parallel lines. Call that the magnitude of vector A. That's the same thing as the length of the hypotenuse. Your book calls this...
Wait, does it have to be like 2 bars on each side?
That's the symbol for magnitude of a vector.
You said that, right?
Yeah.
Before, yeah.
As I said, it looks like a double absolute value sign.
Yeah.
I didn't make it up. Why did you do that?
You're so stupid, though.
I'm with you. Okay, here we have A sub y, to use the book's notation. And A sub y has a magnitude. If you want to find out how high this is, find the magnitude of the vector, multiply it by the sine of this angle theta. That's your that's just a fancier way to write the Algebra 2 idea that to find the... Pardon?
Oh, A-Y.
A sub y, yeah. That to find the length of the vertical side of a right triangle, the opposite side from theta, you use the sine. If you want to know the length of the adjacent side of the angle, which now we're calling A sub x because it's the horizontal component, that length is again going to be the length of the hypotenuse, which now we're calling the magnitude of vector A, times the cosine of angle theta. These are going to be calculator problems. Some of you get to these in pre-calculus with me. You'll have to know some non-calculator stuff because I'll make you do at least some for 30, 60, 90, and 45.
Wait, so that's why they asked us yesterday about, or...
Friday's homework, yeah.
About, like, a baseball field or something?
Yeah. It's like, use this to find the horizontal and vertical components.
Okay.
So this was what you needed. If you need to find theta, you can find theta 3 obvious quick ways with your calculator.
Measure. Easiest of all.
I don't think, does your calculator have a built-in protractor? Because I wouldn't, with a protractor I could do that. But theta is going to be...
I never learned how to use a protractor, by the way. Not once, and that's probably the most useful thing I'd ever need.
Probably, yeah. Maybe we'll do that one day. Theta is the arctangent of opposite
the antitangent
over adjacent, right? Put in the ratio with the arctangent, gives you the angle. Everyone in my class should be pretty up to date on this.
Wait.
If not, if you're not, ask Mr. Singer or Mr. Singer. Everyone here has me or Mr. Singer. Use the inverse tangent. That's one way to find it. You can also find it, of course, by saying theta is the inverse sine of opposite over hypotenuse. And it's also the inverse cosine of the adjacent over the hypotenuse.
We only need one, right?
Pardon? You only need one. But if you love cosines and sines and hate tangents, go crazy.
I love tangents.
I'm a fan. I'm a fan of them. They're my favorites.
Tan.
So if you know, and I mean really know,
I like to tan.
if you really know everything in this box, that's good. It's not everything you need to know, but it's a good start. And all this is, there's no information in this box you did not have at the end of geometry. But the labels are all new and exciting.
Not exciting.
Breaking my heart, Alvin. Alright, so this is the big part. Adding and subtracting, multiplying by scalar. Last idea. Last new idea, which you're going to need more for the project than for anything in the book. Are you ready?
I had a burn on my paper.
Take a deep breath. Okay. What's the thing that makes a movie exciting these days?
5,280.
Megan Fox.
Feet in a mile.
Thank you.
Really? I don't know. Maybe I'm old. Okay. If a new movie's coming out, it has any special effects. It has to be
Lightning.
3D.
in 3D.
3D.
Lightning.
What's that, 3D or 3D?
Full of, like, epic explosions.
What are you?
Oh my god,
I
really?
got 3D. Why are you wasting?
40.
Why are you wasting Sarah's time?
Yeah, 40.
It actually looks good.
Yeah, that's actually not bad.
Yeah.
I would have made the other side 3D.
No, that wouldn't
Nobody
have
asked
worked.
you, Rich.
Why?
Somebody cared.
Okay. 3D in 3D.
What's on 3D?
What?
Congratulations.
Yeah, 40.
For 4D, it would have to move through time.
The D looks really fat compared to the 3.
Yeah, I didn't say I was good at this. Anyway,
Well, it took
I
time
wasn't.
to make it.
That's okay. 3D.
It's like
Okay.
vectors in 3D.
A vector in 3D has an x component, a y component,
And Z.
and a z component.
Oh yeah, totally guessed that.
Okay? And the letters that correspond to this,
X, Y, Z.
nope, are I, J, K for the unit vectors.
I was reading.
Alright.